All right, so yesterday we did proportions practice. If you were not here or if you lost that assignment, it's in the blue bin from yesterday, proportions practice. So make sure if you weren't here yesterday, you get that assignment. It's like this warm-up, okay? So getting started here, this is like yesterday's warm-up. What is it called, the way we solve this? Do you remember what it's called? Butterfly or cross multiply and divide, okay? By the way, look at the objective. We're talking about similar triangles today, which has proportions, okay? And quiz next Wednesday, proportions practice is due. If you didn't turn it in, you got to get that in ASAP, okay? So, thank you. So, let's do cross multiply. 4 times 7 is what? 28. And then we cross multiply here, 2 times x plus 1. Now, don't forget the equal sign. And then 2 times x plus 1. X plus 1, you want to put in parentheses, okay? And then we want to distribute, right? Now, 2 times x and 2 times 1, okay? What's 2 times x? And 2 times 1, 2. Okay, so 2x plus 2 over here, bring down 28. And then we want to solve for x, okay? So on the side with x, we want to get rid of the loner. So the loner is 2. How do I get rid of the plus 2? The opposite is minus 2, right? 28 minus 2 is 26. Bring down 2x. And what's my last step? How do I get rid of this 2 right here? Divide by 2. What is 26 over 2? What is 26 divided by 2? 13. All right. Now, we are doing notes on similar triangles and pass this out. Stay with me. Okay. The sooner we get through this, the sooner we can move on to other stuff. So please stay with me. All right, here we go, here we go. Oh, no. All right, so similar triangles, here we are. Similar figures, okay? Do y'all remember in unit 3 or 4, we were talking about congruent? Congruent is the same size and the same shape. Similar is not exactly the same. Okay, it is the same in its shape, but it is not the same size. Okay, so same shape, but not the same size. Cool. Do y'all notice that on this picture? Look at these angles. What do you notice about these angles? They're what? 25 and 25. That is the same, right? 41 and 41. That is the same. The angles are actually going to be the same. Thank you. Now, real quick, let's find this missing angle. How many degrees are inside of a triangle? Do you remember? 180. So to figure this out, I'm going to take the 2 that I know, add them up, subtract from 180. So 25 and 41. Let's do 25 plus 41. Gives me 66. Subtract 66 from 180. I get 114. Okay. So 114 can go right there, that missing angle B. that missing angle E. Okay. Now you can clearly see all the angles are the same, right? So go and write the word similar. When we talk about similar, the two triangles above are similar. The way that we say this in math notation is with the following statement, okay? So similar is this little symbol. Do y'all see that? It's like a squiggle. The name for that is a tilde or tilde or something. But if you take triangle ABC, squiggle, that means similar to triangle DEF. You're telling me it's the same shape but a different size, okay? Now how do we say this? Triangle ABC is similar to triangle DEF. All right. All right, I know I gotta zoom out a lot here. Now, angle A matches what angle on the other one? Angle A matches what? Over here? D, right? So angle D, and how many degrees are those? 25 degrees. Cool. Okay, B, we already figured this missing one out, matches the other one, E, and those are both 114 degrees. And then angle C matches angle F, those are 41 degrees. So basically we see that we have matching angles on each side, and then what we're going to do is for the sides, we're going to turn them into fractions. So AB, between AB, you can see there's a 4 there, right? And between DE, the corresponding side, there's a 6 there. So in that little middle spot right there, you're going to put 4 over 6. All right. Now 4 over 6, if I go to my calculator, new document, don't save, 4, if you just type it in, it'll reduce it for you. Now I hope you can reduce a fraction on your own, okay? 4 over 6 is 2/3. If you get control divide, you can see that 2/3 is 0.6 repeating, right? Okay, so, so 2/3, right? What about BC and EF? So BC is over here, we get 2. EF is over there, you get 3. So we can write 2 over 3. 2 over 3 does not reduce, it's still 2 over 3. And then AC over DF, AC is 5, DF is 7.5. So 5 divided by 7.5. Now, when you type that in, you get the decimal version of 2/3, right? Didn't we already say 2/3 is the same as 0.6 repeating? Well, 5 over 7.5 is 0.6 repeating, so that's going to be the same as 2/3, okay? So all three of these give you 0.6 repeating or 2 over 3, same thing, okay? So again, do you notice how they're all the same? That's how you know that these triangles are similar. If every side that is corresponding gives you the same, what we call scale factor. So off to the right, go and write scale factor in this box. We will get to talking about scale factor more later, but this is how you find scale factor. Okay, you can flip it over once you've got that. We're going to do 2 more pages. The last page, we're going to not do that because we already went over it. Does anyone still need this page? I know it's kind of zoomed out. So let me zoom in a little bit. Hey. All right, we're good? Page 2. Let's write this down real quick. When two triangles are similar, their angles are always congruent. So the angles are always the same between two similar triangles. But their sides are not the same. The sides are proportional to one another. What does proportional mean? Is that what does it mean? If you set up corresponding sides as ratios, the ratios always equal the same number, just like we just did, right? 2/3, 2/3, 2/3, same ratio, same number. Down here, before we do a similarity statement, don't we have missing angles here? How do I find this missing angle A? What do I do with the two numbers? Add them up, subtract from what? 180. So 49 plus 33 is 82. 180 minus 82 is 98. So angle A is going to be 98 degrees. Now notice, 49 matches 49, 98 matches 98, so 33 is going to have to match 33. Because they add to 180, okay? Now I want you to write this, just like congruent, order matters. Y'all remember hearing me say that? Order matters, order matters, order matters. The vertices, the corners, have to match up correctly in the same exact order, or it doesn't work out. So let's see if these are correct. All right, is this right? ABC is congruent to DFE? Let's follow it. A is at the top, 98. B is over here, 49. C is 33. Does DFE follow the exact same order? Nope. No. So ABC should match FDE. That's not the first one. So the first one has the right letters, but not in the right order. So not the first one. You see how like the order has to exactly match for it to be the right statement. What about the second one? BAC. From left to right. Should be DFE. Is that right? That says DEF. No, no, no. Okay. So again, the order wasn't matching. What about this last one? CBA. 33, 49, 98. EDF. 33, 49, 98. The last one is in the right order. So you don't always have to start alphabetically like ABC. What matters is, are they matching in the right order? Okay? Order matters. It has to match. Cool? All right. Now, is everyone with me at the bottom now? We're going to take what we just talked about with what we learned yesterday, or what we reviewed yesterday, which is proportions. Please. So proportions, like the warm-up. Yes, yes, yes. Proportions, like we did on the warm-up today, and yesterday's notes, or yesterday's warm-up and assignment, is what we're going to use when we're talking about proportional sides. Ready? Okay, we'll be done soon. Just stay with me, everybody. All right? So, okay, now check it out. Look. When you have two triangles that are similar, do you see how they drew lines to the corresponding sides? I want you to do that. Every time you see two triangles that says they're similar, or are they similar? I want you to draw lines from the corresponding sides, okay? So we're going to do it down here in a second, but check it out. Anytime you draw a line that connects two corresponding sides, that's going to be a fraction. So 3, 4.5, that's a fraction. 5 to x, that's a fraction. Let's write that down. Okay, so 3 goes to 4.5, that's going to be 3 over 4.5. Right, equals, and then in the same left to right order, 5 going to x is going to be a fraction. 5 over x. All right, now could you solve that? I hope so, by now. So 5 times 4.5. You don't know, calculate as your friend. I don't know, so there you go. 22.5 equals, and then 3 and x multiply to make 3x. And then so, last step, to get rid of the 3 in front of x, we're going to divide, right? Divide by 3, divide by 3. What's 22.5? Oh, divided by 3. 7.5? Okay, so 7.5 equals x. Cool. Now, on this next one, I want you, everybody, to draw lines connecting the corresponding sides. So what are you going to draw a line from 7 to connect with what over here? X, right? It's barely been kind of rotated, not really. Shifted over, a little bit rotated, but yeah, 7 and x are corresponding. So 7, draw a line to x. Do it now. Do it now. Do it now. And what does 3 correspond to? 6. Draw the line. 3 goes to 6. Those are your two fractions. Can't you write those fractions with an equal sign and then solve it? So 7 to x means 7 over x equals 3 over 6. That's kind of an easy cross multiply and divide problem now, right? Let's do it. All right, cross multiply. 7 times 6 is 42 equals 3 times x is 3x. Last step is to divide by 3. What is 42 divided by 3? Anyone? 42 divided by 3. Okay, 14. All right, so those are the simple ones, simpler ones, where you're just connecting them, making two fractions, cross multiply and divide. Flip it over. I'm going to show you 3 ones that are a little different, maybe a little more complicated, and then we're done. Okay? All right, here we go. This says, are these triangles similar? Well, you can't just look at it and know it, okay? Remember on the front page, we connected all 3 sides and all the fractions were the same? That's what you're going to do here, okay? Now look, this has not just been shifted over, right? Like look, isn't this bottom kind of flat? And this is not just shifted over. What has happened here? What happened to get from here to here? What do you think? Anyone? What do y'all think? Yeah, everybody, think about this. What happened to get from here to here? It didn't just move right. It rotated. That's the word. Okay, so this rotated a little bit and got a little smaller, right? Okay, so what does A match up with? E, D, or F? E, right? A, rotating, is now matching up with E, okay? So I want you to keep that in mind. Everybody, draw your lines. Connect the numbers. Does 9 go with 6 or does 9 go with 3 if it's been rotated? What do y'all think? 3, okay? Because it's been rotated. So check it out. 9 goes to 3. What does 12 go to? Okay, 12 goes to 4, and then 18 goes to 6. All three of those connections, let's write all those fractions out. 9 to 3 is 9 over 3. 12 to 4, 12 over 4. 18 to 6. Now here's what I need to know. Do they give me the same number? What is 9 over 3? 9 divided by 3. 3. Okay, what's 12 divided by 4? 3. What about 18 divided by 6? Hey, are they the same? They are, right? Since we got the same proportion, that means that these triangles are similar. Yes, because they give you the same ratio. Okay, so yes, they're similar. And now look, we need to write a similarity statement. The statement is when you draw the little triangle ABC. This first triangle, ABC, is similar. What's the similar symbol again? It's like a squiggle, right? It just looks like that. So ABC is similar, and then match them up. What does A and B and C match up with again? EDF. So triangle EDF. Is everyone seeing how this works? That order matters. If it's rotated, you got to think a little rotatedly. That's a word, okay? Now, on number 2, do you think it's been flipped or rotated? Because it could be either one. You know, you can rotate it like 180 degrees. It'll look like it's been flipped. Which one do you think it is? Who thinks it's been flipped? Number 2. Who thinks it's been rotated? Okay. There's one way to find out, and it's this statement, okay? So the first letter is A to D. Now that makes sense no matter what. So the next letter, B, goes with E. So if it was flipped, B would still be on this side, right? But B goes to E, which is way over here. So this has actually been rotated. Okay? This is a rotation. Okay, so let's solve this. What does 11 connect to? What does it correspond to? 35. And what does 4 correspond to? X, right? Okay. Now, can you make two fractions, set them equal, cross multiply and divide? Like we did on the last page. Can you do that? Let's do it. 11 over 35 equals 4 over x. Please remember, if you go left to right on your fraction, you have to go left to right on your other fraction. You have to be consistent. Can you cross multiply and divide this? Okay, 35 times 4 is 140. 11 times x is 11x. Divide by 11. What is 140 divided by 11? Control Enter will give you the decimal, 12.727, which rounds it to 12.73. I did that a little bit faster because it's a lot of the same proportional stuff. Do you understand how to set that up and solve it? Any questions on it so far? Okay, we're only going to do one more together. This is the big one at the bottom here. This one is probably the most confusing, so I want everyone to hear me as we're going over this and look at what we're doing. Okay, now look, number 3. Does everyone see that there's 2 triangles? Hey, can you get him? Tap him on the shoulder. I want you to see and hear this, okay? So, do you see how there's a small triangle inside of a bigger triangle, right? So go ahead and outline the smaller triangle, right? We see we have a 7 and a 9, okay? So that's obvious. We have a 7 and a 9 on the small triangle. The bigger triangle is where people get messed up. So off to the right, I'm going to redraw the big triangle. Try to make it better than that. Whatever. Okay, so on my big triangle, What is the bottom length of the big triangle? 17.5. Okay, that's the easy part. Now, is everyone looking? This is where people mess up. I want everyone's eyes. I want you to pay close attention, everybody. Okay? Now look. This big side has two parts, 9 and x. What do you think I should write over here for the big side? 9x is wrong. I'm sorry, it's wrong. Now here's why. You multiply to make 9x. But if I have two parts, I'm not going to multiply them, I'm going to add them. Okay? So I know why. I know it kind of makes sense to make it 9x, but do not write 9x, okay? That would be multiplying. How do you add 9 plus x? What is 9 plus x? Not 10. 9 plus x, it's not really a trick question, but the answer is 9 plus x. Like, you can't combine it. They're different things, okay? So literally, you're going to write 9 plus x. If you want to put it in parentheses, that might help you see that it's one thing. Okay, so now do you see how you have a small triangle and you have a big triangle? This is the part where people mess up because they're going to put what? 9x, right? It's not 9x. 9 plus x. Okay, now I want you to connect things. What does 7 connect to on the big triangle? 17.5, right? So 7 goes to 17.5. 9 doesn't go to x, it goes to 9 plus x. Okay? Is everyone seeing what the most common error is? Most people want to say 9 to x. It's the whole thing, 9 plus x. Okay? So 9 goes to 9 plus x. Can you make those two fractions and then cross multiply and divide? Let's set it up. 7 over 17.5 equals 9 over 9 plus x. This looks like, to me, similar to our warm-up. So since we've done this a few times, I'm going to cross multiply and divide real quick, okay? 9 times 17.5 with the help of my calculator is 157.5. 7 times 9 plus x is going to be 7 parentheses 9 plus x. I'm going to distribute the 7. 7 times 9 is 63. 7 times x is 7x. Bring down 157.5. And then we get rid of the loner 63. Minus 63. Gives you 94.5. And then to get rid of that 7, we divide by 7. And we get 13.5. I did that a little bit faster because we've already done these types of problems and we're running out of time. So I'm going to pass out your assignment. You have tomorrow, you do have class time to work on this, but if you want to get started early, I'm going to give it to you. Please don't lose it. Now, the very back of your notes is just more practice. You don't have to do that. I think y'all have gotten enough practice on proportions, so don't worry about the back of the notes. You can just start on this similar triangles assignment. Take the pass.